Good morning to all. Myself Lokesh Kumar Ghosh, PGT Chemistry in Delhi Public School, Dhenkanal, Odisha. So I will discuss in chemistry topic, that is shape of covalent molecules based on Vspr theory. So Vspr theory, valence shell electron pair repulsion theory. So this is one theory by which we can determine the geometry of molecules, of covalent molecules. That is, you know that covalent molecules which form due to the sharing of electrons. So in covalent molecules, the geometry due to the formation of geometry due to the bond angles. Okay, so this theory, Vspr theory, based are having some postulates. There are so many postulates are there. So today in this topic we will discuss or we will emphasize on two postulates. First one, that is the molecules are, the geometry of molecules are so that or form in that postulate which is the bond distance will maximum and repulsion will be minimum. That is a maximum bond distance and minimum repulsion. That is one. And second one, that a lone pair repulsion is more than the lone pair bond pair repulsion is more than the bond pair repulsion. Okay. So this is the two. Based on these two postulates, we will discuss the shape of molecules. So the shape of covalent molecules based on the Vspr theory. These are broadly classified into two types. The first one, the shape of molecules based on do not having the lone pair of electrons in central atom. Do not having the lone pair of electrons. And the second one, the shape of molecules based on having the lone pair of electron on the central atom. So these are the two types, main types of the Vspr theory shape of molecules. So the first I will discuss, that is the shape of molecules based on the Vspr theory, that is do not having the lone pair of electrons. So these are again 5 types. Okay, so these are the types are Ab2 type, Ab3 type, Ab4 type, Ab5 type and Ab6 type. These are 6 types. Ab2, Ab3, Ab4, Ab5 and Ab6 type. Okay, so this first type Ab2, where A is the central atom and B is the atom around the central atom. That spatial arrangement takes place between the Ab2, that at a maximum distance and minimum repulsion. Okay, so A is the central atom and B is the atoms around the central atom. Okay, so we can give the shape of the molecules like this also. Central atom, this one is the central atom A, this one is B and this one is B. But again the repulsion takes place between the bond pair and bond pair. Bond pairs containing the electron, so electron having the negative charge, so repulsion takes place. If the shape is like this, then again repulsion between the bonds takes place. If shape is like this or like this, so repulsion takes place. So in this position, this is the minimum repulsion and maximum distance. Okay, so this distance, that is your 180 degree and shape is your linear. Okay, and the hybridization is Sp hybridization. Okay, so these are the example of BF2, BCl2. Okay, so this is the first type of molecules, covalent molecules without having the lone pair. Then second type, that is Ab3 type. So Ab3 type, that is central atom. Again the central atom is your A and the atoms around the central atom, these are B. So we can draw like this shape also. All are 3-dimensional. Okay, spatial arrangement. So these are 3-dimensional shape. Molecules are in 3-dimensional shape. So you see there is many space left and there is a minimum space, maximum space. So bond will turn. Also we can draw the bonds like this. Again there is maximum space and minimum space. So the bonds are adjusting by themselves at a maximum distance and minimum repulsion. So the structure will be like this. You see, it is a plane. Okay, this is, if you join all the bonds, then it is a triangle. So this structure or the shape, that shape is known as trigonal planar. And you know the bond angle trigonal planar 360 divided by 3, that is 120 degree. Okay, and the hybridization is your Sp2. Previous one is Sp, this one is Sp2, and these are example BF3, okay, BCl3, etc. Okay, this is known as trigonal planar, this Ab3 type. The next one, Ab4 type. So in Ab4 type, A is the central atom, only one, always central atom is one. Then B4, the atoms around the central atom, 4 atoms are there. So we can draw that shape or geometry. We can arrange the atoms in a geometrical like this. Okay, we can you see the space below and above. These are the maximum space. Okay, then bonds are arranged like this also, like this. Okay, you see this shape of molecules Ab4 type, that is maximum distance. If you close the bond towards this bond, then again repulsion takes place. Repulsion takes place, again bond bends to maximum distance. This is the maximum distance and minimum repulsion shape, and this shape is known as tetrahedron. Tetra means 4. It having the 4 phase, 1 phase, 2 phase, 3 phase and 4 phase. And bond angle 109.5 degree or 109.28, 109 degree 28 minute. And the hybridization is Sp3, and the examples are CH4, CCl4, SiCl4, etc. Okay, so this is the third type. And next Ab5 type. Ab5. So in Ab5 there is 5 atoms around the A, means central atom. Okay, so this central atom A, B are arranged in a such a way that there is maximum distance and minimum repulsion. Okay, so this is the arrangement you see. This is the arrangement. This arrangement is known as Trigonal Bipyramidal. This one is triangle, and at the below there is one triangle, and at the above one triangle. If you join this one, one triangle will be formed. So this is known as Trigonal Bipyramidal. Okay, these bonds are known as equatorial bonds, and above the triangle and below, these are known as axial bonds. And the bond angle between the equatorial bonds 120 degree, and axial and equatorial, this bond. Okay, this is your 90 degree. Okay, so this shape is known as Trigonal Bipyramidal. Okay, so the hybridization is your Sp3D. Okay, and suppose example PCl5, PF5. Okay, so these are related with this structure, that is Ab5 type. Then Ab6 type. In Ab6 type, there is 6 atoms around the central atom. Okay, these are arranged at maximum distance and minimum repulsion like this. You see. First square, this one is square pyramid, square bipyramidal or octahedral. This is known as square bipyramidal or octahedral. And bond angles you see, bond angle 90 degree, all are 90 degree. If you rotate the geometry, then same shape will be formed. Square bipyramidal, square bipyramidal, square bipyramidal, square bipyramidal. So this geometry is square bipyramidal or octahedral, having 8 faces. 1, 2, 3, 4, 5, 6, 7 and 8. So it is known as octahedral. And the hybridization Sp3 D2 or D2 Sp3. Okay, and example SF6, okay, or TF6, SF6, TF6, etc. So these are all about the covalent molecules that is do not having the lone pair of electrons based on Vspr theory. Then next important type, that is the shape of covalent molecules having the lone pair of electron on central atom. So in that part we will discuss the geometry will slightly distorted, means disturbance of the structure of the geometry due to the presence of lone pair. And we know the lone pair bond pair repulsion is more than the bond pair repulsion. Also lone pair repulsion is the most, means greater than the lone pair bond pair and greater than the bond pair. That method, that postulate will be applied here. Okay. So first case, Ab2E type. This is one type. Ab2E type, Ab2E2 type. You have to remember like this: Ab2E type, Ab2E2 type. Then Ab3E type, Ab3E2 type. Okay, Fb4 E type, Fb3 E2 type, then Fb5 E type. You have to remember like this. But in your book, it is given some Fb3 E type is given on after the, that is before the Fb2 E2 type. So you arrange these structure. These are 7 types of geometry having the lone pair of electron on the central atom. Okay, so first type Fb2 E type. So what are the types? Fb2 E type, Fb2 E2 type, Fb3 E type, Fb3 E2 type. Okay, Fb4 E type, Fb4 E2 type. Okay, then last one is your Fb5 E type. So first Fb2 E type. So in previous the type 1 of geometry, that is Fb2 type in the first type. Okay, so in Fb2 type geometry is like this. In Fb2 type, that is without having the lone pair. But if there is presence of lone pair here or here, if there is presence of one lone pair, Fb2 E means one lone pair, only one, E2 means two lone pair. So in Fb2 E type there is one lone pair, then a lone pair bond pair repulsion will be takes place. Okay, then lone pair will be repulse the bond pair and the bond will be bent towards inside, and the bond angle of 180 degree will be increases, and bond angle the below 180 degree, then at the means 180 will be decreases here and increases here. So this is one example of what is the shape. This is not linear, this is bent shape. Okay, and this is the hybridization is your Sp2 hybridization, and this is the one example of sulfur dioxide. This is one example that is having this one lone pair and bent shape sulfur dioxide having the bond angle, this bond angle 119.5 degree, means approximately between 119 and 120 degree this bond angle. So 119.5 degree decreases then less than the 180. Okay, so this is the first type. The next type Fb2 E2 type. In Fb2 E2 type there is two lone pair. In first case there was one lone pair, then now in this shape there is two lone pair. Lone pair repulsion again more. So if there is two lone pair but bonds are same, that is Fb2 E2. So Ab2. Okay, E2, there is two lone pair. If there is presence of two lone pair, then the shape will be more decreased, means the angle will be more decreasing, this angle. Previously it is 119 it was. Okay, now it is 104.5 degree. That is 104.5 degree. Which bond angle? That is water. Okay, that is H2O. H2O, oxygen having two lone pair, HO, two lone pair repulsion, again a lone pair bond pair repulsion in both sides. So the bond angle decreases 1192 to again 104.5 degree. That okay. This the hybridization is your Sp3 hybridization. My example is your H2O, and the bond angle is your 104.5 degree. Okay, having two lone pair. Okay, then next Ab2E and Ab2E2 completed. Then Ab3 E type, there is three bonds. Ab3 E type. In Ab3 E type there is one lone pair. You know that example, that is ammonia. Ammonia having three bonds, NH, 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 and having one lone pair. Okay, so that previous geometry of Ab3 type, that is trigonal planar. You see the trigonal planar, but having the lone pair, it will push the bonds. Okay, and the structure will be like this. The lone pair bond pair repulsion takes place, and the geometry will be like this. You see, this is the geometry. This one. Okay, NH or ABBB. NHHH having the lone pair pushing the bonds. So this, you see the bond angle. This is the what is the bond angle? Bond angle of ammonia is 107 degree, and the hybridization is Sp3. Okay, this is the type Fb3 E type. So this is the type Fb3 E type. Then next type Fb3 E2 type. So in Fb3 E2 type, if we consider the previous shape, that is trigonal bipyramidal. Now I am doing the Fb3 E2 type. If we consider the geometry, that is Fb5 type, you see trigonal bipyramidal. Okay, now we will do the geometry of Fb3 E2 type. If Fb3 E2 type, there is two lone pair. You remove two bond in equatorial side. or equatorial bond, you remove 2 equatorial bonds. Okay, 1, 2 equatorial bonds. Then what is the shape? The shape is T shape. The shape is your T shape, and due to the presence of lone pair here lone pair, the T shape will be just like this. You see, bond angle is less than 180. Bond angle is 175. This bond angle is 175. Okay, due to the repulsion of lone pair and bond pair. Okay, distorted T. Okay, so this is the hybridization Sp3D. This hybridization is Sp3D, and this is the example of ClF3, that is your chlorine trifluoride. Okay, so this is the type Fb3 E2 type. Then next one is your Fb4 E type. In Fb4 E type, there is again we'll consider that trigonal bipyramidal geometry. From that trigonal bipyramidal geometry, we can explain the Fb4 E type. Okay. This is your trigonal bipyramidal geometry. Then Fb4 E type, you remove one equatorial bond. There is one lone pair present. You see the shape, that is seesaw. Okay, the shape is your seesaw. Okay, these are 2 axial bonds and equatorial bonds. There is one lone pair. So there is some band, means inward shape. The bond angle of 180 degree increases. Okay, the bond angle, that is 187. This bond angle is 187. Increases bond angle 187. So you subtract 187 from 360. Then we will get this bond angle. Okay, that is your this is 187, then 173. This bond angle is 173, and these two bond angles, these are 102 degree. Okay, 187, this is your 173, and these two bonds 102 degree. Okay, so this is the hybridization Sp3D type, again Sp3D type, and example sulfur tetrafluoride, SF4, sulfur tetrafluoride. Then next one is your Fb4 E2 type. If we consider again the structure, that is a geometry of octahedral, so from that octahedral we can shape the geometry of Fb4 E2 type. This is your octahedral. So Fb4 E2 type, E2, you remove 2 axial bonds. Okay, you see square planar. Okay, this is your Fb4 E2 type, and having the hybridization Sp2D2, and example is your xenon tetrafluoride. Okay, then last one, that is your Fb5 E type. In Fb5 again we will draw that that is a octahedral geometry. Then from that octahedral we can draw the shape of Fb5 E type. Fb5 E type means only one lone pair is present. Okay, only one lone pair. You see, that is your Fb6 type. Fb6 type octahedral or a square bipyramidal. Then what is the Fb5 E type? In Fb5 E type you remove one axial bond. You see, if there is lone pair, presence of lone pair, so slightly lone pair, what happens? Lone pair will be push the bonds, so the bond angle will decreases or less than the 90 degree. Okay, and having the hybridization Sp3D2 type. This is the hybridization of Sp3D2 type, and example ClF5, that is ClF5 chlorine pentafluoride. Okay, so these are all about the shape of molecules by tools, that is a hand and pen, or we can use the stick or pens, or we can use the rejected pens or pens from the children in the class. Okay, so thank you to all. Thank you. Namaste.